السلام عليكم ورحمة الله يعطيكم العافية. class إن شاء الله اليوم today we will continue with our chapter 9. We started last meeting with the product and repetitive layout, okay, the product focused layout. We discussed the product oriented layout or the product focused layout theoretically, and I promised you last lecture that we are going to have a practical example for today's lecture. Our example is wing component example. This is a very simple and clear example, and I think it will help you a lot in understanding how to calculate for the cycle time. Just to recall, don't forget that last meeting I have defined for you the meaning of cycle time. Cycle time, it is the maximum time that your product could stay, okay, or is allowed to stay in one workstation. The maximum theoretical time that your product is allowed to stay in one workstation. And also I have told you last meeting, okay, if you recall, that you have to make balance for your assembly line by assigning the different tasks, the specific tasks to each workstations. And of course, after you calculate also for the minimum number of workstations needed for your assembly line. We all of this we discussed it theoretically, okay, last meeting. Today with this example we will see how we are going to apply, how to calculate for the cycle time, how to calculate for the number of workstations, and how the most important, how to make the balancing of your assembly line, okay, in order to meet your schedule and not to exceed, of course, the production time or the available production time. Let's start with our example to clarify things. Boeing, okay, wants to develop a precedence diagram for an electrostatic wing component that requires a total assembly time of 65 minutes. So the total assembly time for our product is 65 minutes. Now we have 480 minutes available for production per day, and we have to produce at least 40 units is required from that company in order to produce per day. So for 40 units, we need to produce daily 40 units. The available time that we have per day is 480 minutes. Now staff gather tasks, assembly times, and sequence requirements for the component as shown in figure or table 9.2, and we will see this table in the next slide. Now these are the requirements. Now later on you will understand all of these requirements, okay. Let's start with let's see the given. This is given, of course. As you can see, this is the precedence data for wing component. This is, I will repeat, this is given in the question. This information in this table, it's given in the question, because without this information you cannot really solve the problem, okay. For example, but I would like to clarify things in this table before we start our solution. For example, here we have 9 tasks, okay, in order to assemble our component, our product, okay. Task A, for example, needs 10 minutes as an assembly time, okay. There is no precedence activities or tasks for A. Yani A will be the first activity or the first task to be done, okay. But here, for example, I want you to understand what's the meaning of the preceding tasks, okay. اللي هي task must follow task listed below. Now, for example, B you cannot start with, let's say, task B unless A is already completed. يعني مين النشاط السابق لبي؟ A means that you cannot really start doing your activity B unless or until task A is already completed. Okay, the same, for example, with task E. You cannot start with task E unless also task A is already completed. Okay, يعني after you finish task A, you can start with task E. Another let's say another example here, task F, for example. You cannot do, or you cannot, or task F cannot be done until task C and D is already completed. Okay, so this is the meaning of the preceding activities. That's why we call this, we call later on the network, we call it a precedence diagram. Okay, for example, also you cannot start, you cannot complete, let's say, or task I cannot be done unless task G and H is already done. يعني هون المعطيات ملخص كأنه بقول لك should task, time needed for each task of them, of the 9 tasks, and النشاط السابق, التاسك اللي بسبقه. Okay, and it's very important to know what is the preceding, as I told you, tasks before you start solving the problem. Okay, let's now continue. Let's start with our solutions. Now, this is our net diagram here. We have drawn, as you see, our preceding, we call it our precedence diagram for the, of course, for this problem. As you can see here, just to recall, for example, now we want to draw, for example, activity or task A. Now task A, مين السابق له? It has no preceding tasks. So A will be the first one. That's why we said here it's none. Okay. Now after A, we will draw B. Now look here at B. The preceding task of B is A. So we'll draw a line from A. Okay, a line from A, then draw B. Okay. Now in order to draw C, look at the preceding also task B. So draw a line from B, okay, then draw C, okay, then you can have activity C. Now with D, the preceding tasks is B, so we have to draw a line also from B and draw activity D, of course with 4 minutes. That's why if you can see, C and D are preceding activities to F, and you will see later on. But before that, let's draw E. Now E, what is the preceding task for E? A. So draw a line from A, then we can have task E with 11 minutes per day. Now with our activity F, the preceding tasks for F is C and D. So draw a line from C and a line from D, then you can have activity F. هلا عشان نتأكد شوفوا F مين السابق إلها؟ C و D، والمعطيات F السابق إلها task C و task D, just to make sure. Now after that, let's go to draw G, activity G. Activity G, the preceding for G is F, so draw a line from F, as you can see here, then draw G. After that, H, the preceding task is E, so draw a line from activity or from task E, as we can see here, then draw H. Now the last task is I, the preceding tasks for I is G and H, so we have to draw a line from G, from task G, and a line from task H, then we can have our task I with 3 minutes per day. So this is the way you draw your precedence diagram. Okay, let's continue. Don't forget that we have 480 minutes given in the question per day, and we have to produce daily 40 units, and this is the number of units required per day. So in order to solve for the cycle time is always equal to the production time available, yani the time available per day, divided by the units required per day. Now we have 480 minutes available time per day divided by the required units per day, which is 40. Then we have our cycle time, which is 12 minutes per unit. And just to remind you guys, cycle time, yani this 12 minutes means that our component or our product is not allowed to stay in one workstation more than 12 minutes. كل ما يمر في workstation، كل ما ينتقل من workstation لworkstation الكومبوننت تبعنا للتجميع، ما لازم، مش مسموح له يضل أكثر من 12 minutes in one workstation. That's why we define, I will remind you again that the definition of the cycle time is the maximum theoretical time that our component or our product could stay in one workstation. It should not exceed the 12 minutes. So cycle time, it's very important in any question, okay, or in any problem solving of the product oriented layout. Now, a minimum number of workstations. Okay, now the question is, طب how many, I know already the cycle time, طب how many workstations do I need in order to assemble my component in this company? Now, the minimum number of workstations is always equal to the sum of task time, and we can see here the sum of task times is 65 minutes divided by the cycle time. لأنه كل واحد منهم مش مسموح له يضل أكثر من 12 minutes. So we will have a number, the needed workstations, the minimum number of workstations needed for this in order to assemble this product or this component is 5.42. But guys, هلا بدي أحكي ملاحظة جدا important, very important note. The number of workstations ما بيصير يكون كسر. Like the number of computers. تقدرش تحكي احنا بدنا والله احنا بنحتاج 4 كمبيوتر ونص. Okay? النمبر اوف ورك ستيشنز لازم يكون رقم صحيح ودائما بتقرب للابعد بغض النظر عن الرقم. Like here we have 5.4 42 workstations, which means 6 stations. We need 6 workstations, guys. Even though now, for example, if this number is 5.009, still we need 6 stations also. بتقربوا للستة، مش على التقريب تبعكم للأقل والأكثر. اوكي، إذا طلع عندك الرقم 5.1 اوكي work stations، شو بيكون النمبر اوف work stations؟ 6. بتقربوا دائما للأعلى لأنه ما في جزء، ما في part of work stations، ودائما بتاخذ الرقم الأعلى because you have to assemble your product, you have to complete the operation in order to assemble your product. So please remember this note. Always number of workstations بتقرب للأعلى. okay بغض النظر عن الكسر شو كان صغير. 5.008 5.005 you will have it also as 6 workstations. okay, now let's continue with our example. Now in our example, if you recall, he told us to use the heuristic of the most following tasks. You will see now, I will explain to you this when we are going to balance, when we are balancing our assembly line. Now this heuristic, it will be given in the question. انه okay طبعا as you can see internationally or globally there are 5 heuristic usually. احنا اللي طلبوا منا سؤالنا انه to give the priority for the most following tasks. يعني لما نيجي نحدد to assign the tasks now later on for the workstations and to make our balance, we will give priority for the most following tasks, which means that we have to select the task with the largest number of following tasks. And I will explain to you this in the next slide when we are doing our balancing. Okay, now this is our network, we call it diagram, sometimes we call it precedence diagram, and so on. Let's assign now the different tasks, the specific tasks for the 6 workstations. Don't forget that in this question we are going to have 6 workstations in order to assemble the wing component for this company. Now, station number 1, of course, it will be assigned for whom? And don't forget that the cycle time is 12 minutes, guys. Remember, cycle time is 12 minutes. Now we have 6 work stations. Station number 1 will be, yani task A will be assigned to station number 1. Don't forget that the cycle time for station number 1 is 12. Now, task A will need 10 minutes. So we have an idle time of 2 minutes. هلا idle time guys اللي ما بيعرف الترجمة تبعتها الايدل time means الزمن الضائع. الزمن الضائع لأنه هو here our task is allowed up to 12 minutes according to the cycle time, but it needs only 10. So we have زمن ضائع or idle time of 2 minutes in this workstation. Now the next workstation, of course, will be station number 2. Task B will be assigned to station number 2 with 11 minutes. So we have idle time of what? 1 minute, which is 12 minus 11. So زمن ضائع, only 1 minute. Station number 3. This is 4, by the way. Let's go to station number 3 first. Station number 3 will be, our task E will be assigned to station number 3 with also 11 minutes. So we have idle time also of 1 minute. Now, look at station number 4. Station number 4, 3 tasks will be assigned to this station, by the way. C, D, and F. So 3 plus 5, 8 plus 4, 12. هلا ما بصير يكونوا 13 أقل من 12. Okay, 12 exactly okay because our cycle time is 12. هلا this is a perfect workstation. Why? Because we have no idle time. فيش وقت ضائع. لأنه imagine we have 12 here, 12 minutes, and our cycle time is 12. So 12 minus 12 is equal to 0. So our idle time الزمن الضائع here in station number 4 is 0. Now next station of course will be for task H. So task H will be assigned to station number 5, again with 1 minute idle time because we need for task H only 11 minutes, not 12. That's why we have an idle time of 1. And the last workstation, which is workstation number 6, of course will be for task G and I, okay, with 2 minutes as an idle time. Why 2 minutes? Because 3 plus 7 is 10, 12 minus 10, so we have وقت ضائع of 2 minutes. Okay, this is the summary of the idle time. Okay, this is again just to explain to you further. Okay, so our total idle time in workstation, let's say in the first workstation we have 2 minutes idle time. In the second workstation we have 1 minute, and so on. The sum total of the idle time, مجموع الidle time الوقت الضائع كله في assembly line is 7 minutes, which is 2 plus 1 plus 1 plus 0, of course, because one of them was a perfect workstation. 1 plus 2, so equal to 7 as an idle time. So الزمن الضائع الكلي equal to 7 minutes. Okay, and also if you notice, this is our example, this is the information. Now let's calculate for the efficiency of our assembly time. Okay, what is the efficiency of our assembly time? Are we really utilizing our workstations? Are we utilizing the cycle time? And of course, if we do, by what percentage? الefficiency بيعطيك شو كفاءتك في الاسمبلي line. So efficiency is always equal to the sum of task time divided by, we call it, هذا اللي انتم شايفينه في المقام كله, we call it the allocated time. The allocated time, don't forget that the actual number of workstations is 6, isn't it? In our question. Now multiply by the largest cycle time, which is 12. So 6 multiplied by 12 is 72. So 65. Now this one we call it the allocated time, but the needed time is only 65, اللي هي sum of task time. So 65 divided by 6 by 12, of course 72. So 65 divided by 72 minutes, we have an efficiency of 90.3%. So the efficiency of our assembly time for this component is 90.3%, which is of course a good percentage as an efficiency. So what is, if I ask you, what is the percentage of our idle time? Don't forget that our idle time was 7, okay? 7 minutes. So 7 minutes divided by 72 minutes available, which is of course the number of workstation multiplied by the cycle time. او انك بتاخد الايدل تايم برسنتج هاي اللي هي متمم ال 90، متمم الافشنسي. الافشنسي is 90.3%. so البرسنتج of idle time بده يكون المتمم لل 90.3% which is 9.7%. يعني guys in exams بدك تستخدم موضوع المتمم بيخليك تحل بشكل اسرع. اوكي انا معطيك صح طريقه ثانيه لحساب الافشنسي هون but it's the same. اوكي بس الايدل تايم percentage sometimes we call it the delay. we call it the idle time delay لانه الايدل تايم هو زمن ضايع. طب شو نسبه الزمن الضايع؟ نسبه الزمن الضايع of course which is 7. الايدل تايم total idle time is 7 divided by the allocated time which is 72 minutes. هلا needed time 65 minutes. I want you to understand these things because next lecture I will give you an example, another example. بعطيكم كمان مثال حتى تقوي نفسك. Another example and I will help you. I will show to you how to use the concept of allocated time and the concept of needed time. So we have a percentage. Our percent for the idle time is 9.7, which is the complement of 90.3%. Okay. Now, as I promised you, next lecture I will give you also another example, which is example 2. بس زيادة حتى أنت تفهم أكثر. حاب أعطيك أكثر من مثال. Okay. And we will solve it inshallah next meeting. It's very important to see the video for the explanation of the calculation and to understand what I am saying. And it's very important to attend also to see the next video in order to understand how to solve, how to deal with the problem solving with regard to the product and repetitive oriented layouts. Until then, until next lecture inshallah, I hope you will be always fine and thank you very much.